Hi folks, now that we've seen how to use the sine law or how to make calculations to find missing components with the sine law, we're going to try to apply what we can do with that to some problem solving situations, so some novel contexts or some word problems, whatever way you want to look at that. So let's start with the sine law in context. We're going to apply it to those situations. So the way I like to approach problem solving situations, especially if it's one that you haven't seen before, but you're supposed to have all the tools and skills to get there, it's sort of a three-step process. First thing you do is read and understand the problem. That makes sense, I guess. Then we have to sketch a diagram with all the known values and the missing components. So that's the key thing. Being able to read the information and put the known values in the right places in the diagram and label the missing component in the right places. And after that, if it's a problem that we use the sine law for, then we go through the same steps that we would use when we're using the sine law otherwise. Okay, so let's get started with an example. So this one says we've got a problem situation. A telephone pole is supported by two wires on opposite sides. Now before I go any further, I'm picturing in my head what this would look like. So that doesn't mean it's going to look like that when I try to draw it on your screen there. So that's the ground, which is meant to be level. And then we have this telephone pole here. So a telephone pole looks more or less like that. And then I've got wires that are supporting it on opposite sides. Okay, so I guess we'd have a wire going this way and a wire going that way. Okay, so I've got a wire on either side. So you can look at this, I guess, as being a triangle over here and another triangle there, or as being one big triangle, which is probably the way we're going to end up tackling this. It says at the top of the pole, the wires make an angle of 50 degrees. So they reach all the way up to the top of the pole. So up here, it says the wires make an angle of 50 degrees. So that must be the whole thing if we're talking about both wires. So we've got a 50-degree angle up at the top. On the ground, the ends of the wires are 48 feet apart. So these are the ends of the wires on the ground, and that's a 48-foot distance across there. So we've got 48 feet all the way across here. Okay. And then it says one of the wires makes an angle of 55 degrees with the ground. So it doesn't say which one, so I guess that's kind of arbitrary. We'll say it's this one, makes an angle of 55 degrees with the ground down here. And then we want to figure out how long are the wires. Okay. So what I'm going to do is I'm going to take this and I'm going to take it at a telephone pole land for a minute, and I'm just going to draw myself a triangle, or at least attempt to draw myself a triangle. Let me try that one more time. So let's see what we can come up with when we draw this actually as a triangle now. So I'm going to try to draw myself a triangle here. So there's one side, there's another. This looks a little bit better, not a whole lot freehand. And on this triangle I've got some numbers. I know that this is 50 degrees up here, and I know that this is 55 degrees down here, and I know that this bottom side is 48 feet. Okay, so what we want to figure out is how long are the wires. So let's say wire over here is going to be X units long, and wire over here is going to be Y units long. So we got to figure out what X and Y are. Now if I want to solve for X, remember I need to know using sine law its opposite component, which I have the 55 degrees across that way. And I also have this pair of known opposites with the 50 degrees and the 48 feet, one directly above the other. If I wanted to solve for Y, I might think I'm out of luck, but this is a trick we've seen before. I do know this angle, I just don't know it yet. So remember that all the angles in a triangle have to total 180. So 180 degrees here has to be equal to whatever we're going to have for that missing angle. I don't know, let's call it theta. We can say theta plus 50 plus 55. They all have to add up to theta, to 180. So then your angle theta is just 180 minus 105. So we have 180 degrees minus 105 degrees, which I think is about 75. So this angle down here has to be 75 degrees. So then we can do the two-step, folks. It's a two-step process. We can figure out X using sine law, and we can figure out Y by using the sine law again. So we're in business. So let's start off with finding X. So X over the sine of its opposite side, which is 55 degrees, or its opposite angle, I should say, has to be equal to the ratio of our known pair, which is 48 feet, over the sine of its opposite, which is 50 degrees. And then I'm going to do the same thing with Y. So I'm going to say that Y over the sine of 75 has to be equal to 48 feet over the sine of its ratio, or of its angle, which is 50 degrees. So basically I've got two little sine law equations to solve, and then I should have this problem tackled. So over here, for the x stuff first, I guess I'll cross multiply and get 48. Sorry, I'm going to end up with x times sine 50. Looks a little better. Is going to be equal to 48 sine 55. So then x is equal to 48 times sine 55 divided by sine 50. And if I plug that into a handy-dandy calculator, let's see, 48 sine 55 divided by sine 50. We've got 51.3. So down here, we've got 51.3. Sorry, I'm in the wrong place. Right here, 51.3 units for that one. Or I guess that's going to be feet, isn't it? Because we were talking about feet here. So that wire is 51.3 feet long. And the other one, we're going to end up with y times sine 50, in this case, will be equal to 48 times sine 75. So y is going to be equal to 48 sine 75 divided by sine 50. Okay, so our calculator will tell us for that one we want 48 sine 75 divided by sine 50. And magically we get 60.5 feet for that one. So that one's a little bit longer. So we've got 60.5 feet for this guy. Okay? So those are our two lengths for our two wires we found using sine law. So remember the three steps that we went through for that. Read and understand the problem. Sketch a diagram with all the known values and the missing components, so be careful about how you do that. And then from there, it's just the steps that we already know how to do using the sine law. Good luck.